Welcome back to Wildcat Academy. Today we are going to be learning about factoring polynomials, difference of squares with a GCF. If you've missed the first part of this series, be sure to check out our video on factoring polynomials, difference of squares. Alright, so just a quick review here. We talked about in the last video that a plus b and a minus b were conjugates. So when we multiplied those together, we ended up with a squared minus b squared. So when we reverse that process, we will start with a polynomial in the form of a squared minus b squared right here, and then we will take the square root of the first term, and that will be the first term in each binomial, and the square root of b squared, which will be the first term in the second binomial, and then one will be positive and the second one will be minus, or vice versa. It does not matter if it were to be a minus b and a plus b. But that's our difference of squares method. You can write this answer either as 1 or line 2 there. It will not make a difference. So the little twist we have with these problems is they are not going to immediately appear as if they are a difference of squares problem. So we have to recognize those. So one of the first things we want to do in any factoring problem is simplify the problem by factoring out a GCF. Now when we factor out a GCF, you can think about this as division. So we're going to divide out any common variables or whole number values that will divide into both terms. So as we examine the first term and the second term, we can inspect and see that they are both divisible by 3. So we're going to simply divide that 3 out or factor it out and put the 3 out in front of a parenthesis, and then we will place the binomial inside after we divide both terms by 3. So that will result into x squared minus 25. And we always do a really quick check. We multiply the 3 back in our heads. 3 times x squared is 3x squared, and 3 times negative 25 is negative 75. That ensures that we have done the GCF step correctly. And then once we have completed that step, we look inside the parentheses and we can see our difference of squares problem. We have a variable with an even exponent, and we have our coefficients and our whole number values are both perfect squares, and there's a minus sign between them. So we've identified this as a difference of squares problem. So then we will just form 2 parentheses for our 2 binomials. We will take the square root of x squared and place it in the a spot on both binomials, and take the square root of 25 and place it in the b spot. And one will be plus and one will be minus. Again, you can reverse those if necessary. All right. So looking at the next problem, this one looks like a difference of squares problem from the beginning. A little twist here, though, is that the first term is negative, the middle term is positive. But we can see these are perfect squares here, 4 and x squared and 100. So we're thinking difference of squares, but we need to transform the problem so there's a minus sign between and our first term is positive. As a rule of thumb, we never want to factor any polynomial where the leading coefficient is negative. So we always, at minimum, want to factor out a negative 1 in situations like this. We don't identify any other common factors. Actually, we can factor out the 4. So there is a 4 here, and the 100 is also divisible by 4. So we're going to factor that out and make that negative 4 out front. We could have solved the problem without doing the 4 and left that inside, but it's okay to go ahead. I think it simplifies the problem a great deal by going ahead and factoring that 4 out and dividing it out. It would have been because 4 is a perfect square, it would still have resulted as a difference of squares problem inside had it been 4x squared minus 100. So we have the negative 4 out. We do the quick check. Negative 4 times x squared is negative 4x squared, and negative 4 times negative 25 is positive 100. So we have completed our GCF step correctly, and then we will just do our difference of squares step. which is a pretty quick process here. Take the square root of x squared. Little mistake there. Square root of x squared, which is x, and then we will take the square root of 25 just like the first problem, and one is minus and one is positive. So you can see that these problems look completely different even though they have two major components that are the same. The x plus 5 and the x minus 5 are the same in the final step of both problems in the complete factorization. Their GCF was simply different. Looking at example 3, negative 18x squared plus 50, we start thinking that it might be a difference of squares problem if we're just examining this outside the video, trying to wonder what method we might want to be using because of the two terms, and there's an even coefficient or even exponent on our variable. So we want to go ahead and take the GCF out, which is kind of masks the look of the difference of squares problem. So we're going to factor out a negative 2. So we're going to divide both terms by negative 2, both coefficients, and that gives us a positive 9, x squared minus 25. And then that will reveal the difference of squares problem. And then we just draw our two parentheses in order to do the difference of squares problem. We will take the square root of 9x squared, which is 3x, and the square root of 25, which is 5. So in our head here, we took the square root of x squared and the square root of 25, and that revealed the value of a to be 3x and the value of 25 to be 5. And that gives us 3x and 5. One's positive, another one's negative. There are no other GCFs left in the problem that we missed, so we can move on to the next one. So here, the little wrinkle in this problem is that there are variables in both terms. And once again, we do have a GCF in both terms. We're going to start by factoring out a 10. And then we will be left with 25x squared minus 144 y squared. And factoring out that GCF always simplifies the problem, even if we had not needed to in order to do difference of squares. You can see that the numbers get much smaller and more manageable whenever we do that. And once again, our process is going to be exactly the same. We're going to take the square root of 25x squared. So the square root of 25 is 5, and the square root of x squared is x. And then this, for conjugates, remember we're going to result in conjugates every time. So the first terms are going to be the same, and then the second term will be the same. And one will be positive, and one will be negative. And that's really important. Now, conjugates show up several places. We deal with those with radicals and also complex numbers, but it always results, the product of conjugates will always result in a two-term binomial, regardless of the complicated terms that they may be, whether they're radicals or they have I in them with complex numbers. All right, so example 5. Again, we're going to have a GCF. You can see that the problems continue to become more complicated. We have, again, this is the first time we haven't seen an even exponent on our variable. So it further masks the problem because we have a GCF that has a variable this time. So we have, you see that we have an exponent here of 3 and an exponent here of 1. Usually we can determine which problems are difference of squares because they have even exponents and a minus sign between. So again, when we have a variable GCF, that can mask the problem. So it looks like both of these are at least divisible, both numbers are divisible by 5, and there is a variable here of x that we can see that and identify that because we can take the lowest exponent out of both terms. So there's an exponent of 3 here and an exponent of 1 in the second binomial or second term. So we will divide that out, and we will result in 9x squared minus 25y squared. And then when we do the quick check, 5 times 9 is 45, x times x squared is x cubed. I can't stress the importance of doing that to make sure that you have done that GCF step correctly. 5 times 25 is 125, and then x times y squared is xy squared. And that results in the difference of squares. It reveals itself very clearly then. And we will take the square root of 9x squared, which is 3x, and the square root of 25y squared, which is 5y. And then one will be plus and one will be minus. All right, so last problem here. You can see that we have variables in both terms. We have a negative coefficient, putting all the examples together. And one final difficult problem here. So we definitely want to take out a negative because we do not want a leading coefficient that's negative. Looks like both terms are divisible by a 2 minimally. And then we have an odd coefficient here. We have x to the first power, so we can take out an x. So we want that'll leave a x squared here, and no x's in the second term. And here we have y squared and y to the fourth. And this is a little tricky in the fact that both exponents are even, but again, because we have y's in both terms, we can add that to our GCF, and we can take out the y squared. And that will leave us with 36x squared minus 49y squared. Again, we want to do that quick check because, again, we have a very complicated GCF here. Negative 2 times 36 is negative 72. X times x squared. 1 plus 2 is 3 x's there accounted for. And then y squared accounts for both y's in that first term. And then negative 2 times negative 49 is positive 98. X will account for all the x's in that term because there are none left. And then y squared times y squared, 2 plus 2, gives us the 4 that we started with. And then we can just do our difference of squares step, which in this problem I think is the much easier step than factoring out the. So we will now take the square root of 36x squared, which is 6x and 6x, and the square root of 49y squared, which is 7y and 7y. One's plus, one's minus, and our problem is complete. Well, that winds up this lesson today. If you enjoyed the lesson, found it valuable, be sure to hit the like button below. And if you haven't already done so, subscribe to the channel and look out for more great videos from Wildcat Academy.